So for the dust particles, first we will need to create a velocity field that will drive the movement of the particles. So we're going to create a pyro simulation that's going along this direction. Now you can give this any direction that you want, but I just wanted this to be perpendicular to the height of the composition. Essentially, I found that it created the most interesting results, but you can totally create this pyro simulation from whatever direction you want. So to create this simulation, we need to start with some geometry. Let's go ahead and over here below, let's start with a simple grid, and we no longer need to preview our snow because it might slow down the viewport. Let's just preview our, let's see, our Boolean result instead. So only our geometry, turn off the lighting, and we only really need this as a reference. So I will template this by pressing E. Let's go to our grid. And let's also hide other objects. And I'll leave this grid as it is, and I will do a transform node instead. And I just want to move this so it's perpendicular to this ground. Hold down Control so we can rotate this. And let's drop the uniform scale quite a bit. And then I can also press E on my keyboard to just scale this. So I can move this grid. So E, R, and T. Let's go ahead, and I want to increase this so we can imagine that if the smoke starts blowing from here, we want it to cover this entire geometry. So let's place this roughly into a position, and we want to also make this as small as possible on the height, so on the X value here, because our particles will be precisely on the surface of this plane. So we don't really need a lot of information. If this plane were like this, we don't really need this velocity information over here. We only really need this pyro simulation to be affecting areas around the surface. So we can optimize this a little bit by making this grid as small as possible. So I think something like this should be okay, maybe even smaller. All right, so from here we can do a scatter and create our pyro source. We can also use a pyro source node, but I will keep this simple and just use a regular scatter. Let's disable relax iterations and just make sure that we have enough points here. As you can see, I'm pretty much just eyeballing this. We just need this grid to be filled with points. Let's go ahead and create a cool density attribute. So we can do this inside an attribute of op. Let's rename this to set density. And we want just a simple noise that animates. So let's step inside and we will use a turbulent noise. Let's plug this into our CD to preview this. We will set this to simplex. Let's also do a fit, and I want to animate this noise on the x-axis. So with our time, we can do a float to vector, and if I plug this inside the offset and press play, we can see our noise is animating, so we are on the way. And now we can just promote the inputs for these. So right click, create input parameters, and for the fit as well. So now I can go up and I can increase the frequency a little bit. Let's also decrease the minimum value in the fit range. Let's do something like this. And maybe decrease the maximum value as well, maybe add a little bit more contrast. So something like this I think will be fine. We don't really have to spend a lot of time adjusting these values. And now let's turn this into smoke. Let's actually first go back to our plane. Let's make sure that it's not intersecting with our geometry. Maybe it's also pointing along this direction here. All right, because later we are going to collide our smoke with geometry generated from the snow, it's best to have a little bit of padding between these objects. So I think this will be fine. We can come back and adjust this later if necessary. Let's go ahead and do a volume rasterize attributes. And before this, actually, we are only exporting the color here. So let's step inside and also do a bind export after our fit to export this to essentially create this density attribute. So I'll copy this. And let's go up and place this as our attributes inside the volume rasterize. We can start with fairly low values here. Let's make our particle scale match our voxel size. And let's go ahead and just drop this inside a pyro solver so we can straight away match the voxel size of our rasterize with this here in our pyro solver. So let's grab this parameter, copy parameter, and let's paste relative here. So now pyro solver and volume rasterize nodes will use use the same values. And I'll leave this at 0.1 just so we can do some tests. But first we will need to create a velocity field for this, and we will need to start with some geometry, and we can create this from our grid. Let's go to our transformed grid over here, and to the right we can do a poly extrude, and let's press enter in our viewport, and let's just extrude this so it covers our entire ground. So we can do something like this. And we also need this to be a filled mesh, so output back should be turned on. And now we can use this to create a velocity volume. So let's drop down a VDB node. We can rename this to V. Let's set the class, we can keep this at fog volume. For the class type, we will use vector float. And for the vector type here, we want displacement velocity acceleration. Okay, and we will probably need to link the voxel size as well. So let's go to our pyrosolver, copy parameter, and link this up with our VDB. Okay, so now we can use a VDB activate, and let's plug this as our second input and set this VDB activate to reference. So if I go to this, here we have our velocity field. Now currently these are all initiated at a value of 0. So let's go ahead and do a volume VOP. And to visualize this better, let's go ahead and drop down a null from here. So this will be our velocity field. And we can do a volume slice and then plug this into a volume trail, which we can point back to our velocity field. And for the volume slice, let's use a different plane here. Let's use ZX. So if I go to this volume trail, we can preview our velocity like so. So back in our volume VOP, let's go ahead and get rid of the density. We no longer need this, and we will do a bind export, and we want to modify our V volume. So let's do a bind export and set this to V, which is a 3 floats type. And I will start by dropping a constant and just giving this an initial direction. So this constant, let's also set to 3 floats, and I can plug this inside our bind export, and now we can determine the direction that we want. So we can play around with our values here. For example, if I increase this on the X direction, we get this direction over here on this side. Now we need this to go the other way around, so we can set this to a value of -1. And it's a little bit hard to tell the direction of these vectors like this, so we can introduce a little bit of noise, which we have to do anyway. And we can do this inside the volume VOP as well, but I prefer doing this with a volume velocity node at the SOP level. So if I go up, let's make some room over here, and I will drop down a volume velocity. So let's plug this here and go to the kernel noise, and let's hit this add kernel noise option. All right, so now we can also kind of tell the direction that this is headed. Let's do a couple of volume velocity nodes, and for the first one, I want to use a big swirl size and a smaller scale, something like this. And if I play the animation, I can also kind of get an idea of the speed of this noise. So I think this is probably okay. And then I can duplicate this noise and add it over here on top. And for this one, I will decrease the swirl size and decrease the scale for this quite a bit. All right, and maybe I can also introduce a little bit more grain, and I want to change the offset. And for this one, we can make this a little bit faster. So I can decrease the pulse length here, maybe to 0.5. So if I play this, now we have a lot of variation in our noise. I can also preview this through the camera, and we can check our direction. And we can see that this is going along the X, but I kind of wanted to have a little bit of movement in this direction as well. So I want to change my initial values here. Let's go back inside our volume VOP. And I think I might want to add some movement on the third value here. So the amount on the Z axis. So let's increase this to maybe 0.8. And I think I prefer this direction better. So we can kind of imagine that this is how our particles will end up moving. Also in this volume VOP, I want to randomize the magnitude of this vector. So we are going to use a 1D noise. Let's plug the P inside a turbulent noise, and let's do a fit range. And actually a cool thing that we can do here, let's get rid of this, let's go up and let's go to our set density attribute, so to our attribute VOP, and I can go inside here and actually grab all of these, so these three nodes, let's Control C, and we can paste them inside the volume VOP. So this is something really cool that I didn't know for a long time. And now all we have to do is plug the P inside our position and the time in our first value of the float to vector. So if I go to, let's disable the volume velocities and preview our volume trail without the velocities. Let's go back inside our volume VOP, and this initial vector that we created, we are going to multiply with our noise. So if I plug this here, we now have some variation in our magnitude. And since these attributes are already promoted, we can go up and I can play around with the frequency, but mostly I think I will want to normalize this a little bit, so I can change the minimum value here and probably the maximum value as well. All right, so we end up with this animation, and we can see that this is swimming across on the X direction here. Let's go ahead and for our float to vector, we will plug this as our Y value. So now it will kind of look like it's evolving. All right, and let's go back. Let's re-enable our volume velocities. So this will be our velocity field. And also a thing that happens here is we see that our volume velocity noise now has a bigger influence on our initial vector, and this is because overall we lost a little bit of the strength of the initial values that we set with the volume VOP. So we can compensate this a little bit. If I go inside, we can actually, because we have the values from our fit range, we can go up and we can increase the maximum and minimum values here. So I can increase these a little bit, and we can see now that this forces our vector to maintain its original direction a little bit more. So we can do something like this, and also for our minimum value. So we just have to be mindful of how all of these come together.